Welcome. This video explores how the natural response of an RC circuit has a negative value for capacitor current. The exploration clarifies both reference polarities and RC natural response. Given an initial condition capacitor voltage across both the capacitor and resistor connected in parallel, we know that the voltage decays exponentially over time. This is natural response. Why will the RC natural response current through the capacitor be negative? From the capacitor branch relationship equation, we know that the current through an ideal lumped element capacitor is proportional to the derivative of the voltage across that capacitor. The derivative of the voltage as a function of time gives us the slope of the voltage function. In this RC natural response example, the voltage is positively valued and decaying exponentially over time. The decreasing voltage function has a negative slope. The negative value of the derivative term of the capacitor current equation makes the current through the capacitor negative. For RC natural response, the negative capacitor current appears right in the capacitor current branch relationship equation.
We have now seen where we get negative capacitor current from looking at the branch relationship. Next, let's look at how this negative capacitor current appears in the formal circuit analysis of this RC natural response. Look at the reference polarity. Look at the direction of the current Ires relative to the polarity of V of t across a capacitor.
The capacitor current I sub C is negative because it points in the opposite direction from the flow of current Ires caused by the capacitor voltage V sub C of t. Let's look at the details for greater insights. If we put 5 volts across a resistor connected to ground, we get a positive current flowing down from the voltage to ground. This corresponds to a resistor reference polarity with the voltage plus sign at the top. Reference polarity relates to the branch relationship of a resistor. From Ohm's law, we know that the higher the positive voltage across the resistor, the higher the positive current flowing through the resistor. Conversely, if the voltage across a resistor is negative, that means that a negative current flows through the resistor. For a capacitor, current through the capacitor also corresponds to a reference polarity with current pointed from the plus sign to the minus sign. But different from a resistor, a capacitor can have current that is negative relative to the current reference polarity. The resistor current is positively valued going down through the resistor because the current flows from plus to minus, matching the voltage reference polarity established in the circuit by the initial condition capacitor voltage. That same current, going counterclockwise around the RC circuit loop, is negatively valued relative to the reference polarity of the capacitor voltage. This is why the RC natural response capacitor current is negative when the initial condition capacitor voltage is positive.
Here is a quick circuit simulation of the RC natural response. The resistor current is a positive decaying exponential. The resistor current is defined by an equation to be the voltage V sub C divided by the 20 ohm resistance R1. Current flowing downward through the resistor is positively valued. The capacitor current is measured by the current probe key R1. The current probe is oriented downward, matching the branch relationship reference polarity current direction of the capacitor. Since the actual current goes up into the capacitor, opposite the current direction of the probe, the capacitor current is negative.
For a capacitor with a voltage across it, the current flowing through the capacitor can flow in either direction, depending upon the derivative of the voltage across the capacitor. For a capacitor voltage that is decreasing, the current through the capacitor is negatively valued. Kirchhoff's voltage law, KVL, can be used to derive the current through a capacitor as a function of time. Using Ohm's law, capacitor current can be calculated from the capacitor voltage, but that yields resistor current as shown in the simulation example. Capacitor current will be the opposite polarity from the resistor current. Thank you for watching and learning with us.